Okay, what's up guys? My name is Sora, or that's how I'm known on the internet, and today I'll be showing you guys a new game engine that I developed using Love, or some may call it Love Duty Game Engine. Anyway, the real name is Love Game Engine. So my engine itself is targeting Love, because even when programming in my game engine, you'll be actually calling from time to time Love functions, but the engine gives you extra features such as pre-built game structures, cameras, scenes, objects, input manager, and a few more stuff to write your game faster. So let's get started. Okay, so here is the directory of the engine's roots directory, and to start a new project, so we simply need to go to projects and create our directory here. So I created the directory called project X, which we'll be testing right now. And once we create the directory, we need to create a file which is called init.lua, and that's because when we start the engine, there we go. So unstart the engine, and this is the engine's main interface. So I hit F1 to open the toolbox, and I'm gonna hit load project, and here I need to type the name of the project. So in my case, project X, it will search for a folder called project X inside projects directory, and it will parse a file called init.lua, which will contain our code. So that's why we need to create this file, and I have it here. There it is. This is our file. It's empty. We're gonna write our code here. So our new game. Okay. So I'll hit apply, and yeah, it loaded the file correctly, but since we have no code, nothing's going to happen. We have no scenes, no actors or objects, nothing. Anyway, so let's get started with coding. The source code here in my other screen, so I'll just copy paste in order to I would not want to make video way too long, because it's just a demonstration, not a tutorial. Okay, so first thing to do is to import the game structure. It's used by the engine in order to update your game objects, your game scenes, and input managers. So that's it. Next thing we need to do is to import the asset manager. So the asset manager will allow us to import images, such as I'll be using these. We have player UFO1, 2, 3, and 4. We'll be using these images, and we'll import them. Okay, so we first require the asset manager, which will give us the asset manager class, and then we need to instantiate it, so we call the create function. So we have an instance of the asset manager, and now we can import our sprites by registering them into the asset manager. So asset manager register, so for each asset we give it a unique identifier. So yeah, there's something that we need to mention here, is that when we register a sprite, so we give it the first parameter is the identifier, and the second parameter is the file path. So here it's called chips /player.png, and it will search for that file inside assets folder. So we first need to create assets folder and then put all our assets here. We could change the assets folder, the default search directory, by accessing the asset manager folder equal whatever you want here, but I won't be doing that, so I'll leave it by default. Okay, so so we import the chips player.png, and we name it player. Same thing for UFO1, we name it UFO1, 2, 3, and 4. Try this. Okay, so yeah, I want to say that the player rotation here should be by default it's rotated like this, and I rotated it this way because its rotation like this is equal to 0. But if we use it like this, if we import it like this, its rotation will be 90 degrees, and we need to each time we do some calculations over object rotation and something, we need to subtract 90 degrees from it. So that's why by default I flip it this way, rotate it this way, so it be 0 degrees. Next thing is to import our object class. So we import the object. This will allow the object classes will allow to create as many objects as you want, and I'll just copy paste the code here. Okay, so local O1 or object1 equal object.create. Sorry, I have to point to object create, and first parameter is the identifier of the object, and second parameter is the sprite that we will use. So I call asset manager import sprite, and we will import the asset player. And these two, the two last parameters are x and y coordinates on the screen, the default coordinates. And then here I changed the default object origin, draw origin x and y. That's because I'll just comment them and see what's the difference. Okay. So after doing all that, we need to add our objects to the project. So that's why I'm going to call project, which is a global variable here, and add object. So object 1, 2, 3, 4, and 5. This will allow our objects to be displayed in the object inspector in the game editor. So next thing to do is to create a scene. So importing scene class. Okay, so we import the scene class and we create an instance of scene. So the first parameter, as usual, is the identifier. We call our scene space chunk, and the scene size. And here, as you notice it, I have this object identifier is called player, same for these assets, but it really does not matter because they are different types, asset and object. And this one scene, for example, you can name this scene player as well. It does not really matter as long as they're different types. But if we have two objects with the same identifier, that will add few more trouble to our life troubles. Nobody wants that. So next thing to do, we add our project to the scene, and with this our scene will be displayed in the scene manager, and then we want our objects to be displayed in the scene. That's why we call scene at object 1, 2, 3, 4, and 5. Now we're ready to run and sample. So hit F1, load project. By default I made this inputs value project X, so I don't need to type it again and again. Okay, so there we go. Import asset, creating objects and creating scene. So for now I'm going to hit the scene inspector, and here I'll see space chunk. So I'll close these, and here there's a bit of lag due to the high quality recording. So as you can see here, I'm going to hit F3 and to open the object properties, and I will attempt to rotate the object. And since it's a spaceship, it should be rotated without changing its position. However, because the default draw origin is 0x and 0 on the y-axis, it's going to rotate like this. So that's why we change the origin offset to 37, I guess, and 59. There it is. Now it's rotating in center. We should do the same things here for the UFO objects. There it is. Yep. Okay. So I'm going to close this, and let's go back to our project. So I'll change the default draw origin because I don't want to change them from the editor every time I start the game. Okay, now we're going to move to controls. So we want to apply a simple animation to UFO objects, and this animation won't actually change the sprite, but they will change the orientation, because UFO rotates, or that's what we know about them. So we'll apply that animation by using controls. So we import our control structure, or import our control class, and I'm going to do that here before I add projects to the scene, but we could do it anywhere else. Okay, so local control equal require control dot control. UFO control, we create an instance of the control class, control create, and we call it UFO rotation. And what we need to know about controls is that they're called every frame, but you can change that. You just simply to store, make some kind of timer or something. Anyway, so they're called every frame. So we need a function. We need to define the update function of the control, which is a function, and have two parameters: self, which is the current control, and dt, which is the delta time. Yeah. So here, every frame, we will change the rotation of the object. So self.parent.rot, and parent here refers to the object in which we assigned the control. So parent.rot, which means rotation, equal self.parent.rot plus 0.08, and it's in radians by default. Okay, then we need to apply the control to the objects. So we'll apply it only to the UFO. We don't want the player to rotate like a not a UFO after all. He's beating them. So go to project, apply. Yeah, there we go. And scene inspector, space chunk. I'm going to close this, minimize this, and drag the toolbox here and start simulation. And there we go, they are rotating. Yeah, the FPS is a bit low because of the recording. Yeah, every time I move my mouse it gets slower and lower. So I'll move my mouse slowly. Okay. And now we made a simple animation using controls. If we want the UFO objects to rotate in some kind of by using a timer, we simply we add a new variable to the control, which we call, for example, timer equal self timer plus t, and if self timer is not yet fulfilled, for example, if it's inferior than 10 seconds, if it's superior than 10 seconds, then we will do the animation and turn the timer back to 0, and let's just keep increasing, but I won't be doing that. And we need to define the timer right here. So in the first call it will be nil, so timer need to initialize it to 0. But again, I won't be doing that. And now we'll be handling events, keyboard events. So I'll be importing the keyboard input manager class, or I'll just create an instance directly. So just come here, just under the control, and import the keyboard manager. So local input, which is an instance of our keyboard manager, because we used to create here. So we will require input manager, keyboard input manager, and create. So now we have an instance that we need to assign to the game. So game add keyboard input manager and input as a parameter. Then yeah, so we need to talk more about controls here. Let's say that there is a control, but first thing about controls, what are controls? While designing the engine, I thought of controls as various behavior that objects can have. For example, a player might be moving, so this is a control, might be rotating, so this is a control, might hit enemies, this is another control. It can do a lot of things, and in order to divide them, we split them into controls. So that's what controller are used for. And then yeah, so the keyboard manager handles input. So for each input, a key, a button, and for each type press, so you either press the button, release it, or hold it. We have a certain control to call or to enable. So by default, event controls are disabled, and when you hit that button with that particular task or that particular that particular key press button, we will have that control will be enabled, and it will be enabled, and it will be called, and then it will be disabled, unless if you're holding it. If you're holding it, as soon as you press, it will be enabled, and once you release, it will be disabled. So that's how they operate. For example, here, if you hit the Z button, because my keyboard is dirty, so if you're QWERTY, if you hit the Q button, the chip will keep moving forward, and if you release, it will stop moving. So that's basically it. However, I'll use a different philosophy here. Let's say that the chip has some kind of speed. So I'll go here, O1 speed equal, let's say for example by default it's 0. So this is chip speed, and there is a control which is always enabled, and that control allows the chip to move either forward or backward depending on speed. So the chip speed is like 400, it's moving forward like 4 pixels in each frame. We'll alter that a bit later. And if it's moving backward, so it's negative, so it's like moving, let's say the speed is minus 400, it's moving like 4 pixels each frame but backward. So that's basically how the control is going to operate. So let's create it. I'll call it chip move. I'll just copy paste the code here. So local chip move equal control create. I'll give it a unique identifier as well, chip move, and chip move update function with self and dt. So we'll change the parent x and y coordinates depending on its rotation. So with few mathematics, you'll notice that we need to increase it by the cos of the current angle and multiply it by the speed or the certain amount that you want to the step, yeah. And on the y-axis, it's sine. That's it. And I'm going to copy paste the other side of the code, which will allow us to limit the speed of the chip. So each time, for example, a car is moving, there is always an opposing force that if you stop if you stop accelerating, you won't drive a car with the button. So, yeah, say real car. So if you stop accelerating, that force will allow the car to stop slowly. So we have that some kind of force here. So if self parent speed superior than 50, let's say speed is superior than 50, so we need to apply that force. If it's negative and it's less than minus 50, we need to apply positive force, so it stops if it's going backward. And if the speed is between the two, we'll change it to 0. Okay, so this is about the chip move, and we need to create 4 more controls for each key button. So chip L rotate, which stands for chip left rotate. This will allow the chip to rotate left. So self.parent.rotation equals self.parent.rotation minus 0.04, and right rotate is same code, but we need to increase that rotate difference. Chip forward move, yeah, this chip forward move will, when we hit the Z button here, it will just increase the speed by 100. We could limit it here, could write a code to limit the speed, but just keep it that way. And if we hit the brake button, the speed will increase, and if we keep pressing it, it will keep decreasing. So it will decrease, and it will keep decreasing as long as we keep pressing until it goes backward. Same for accelerating. So that's it for with the controls. So this one, rotate left, rotate right, and increase speed, decrease speed, and we need to assign these controls to the input manager. So where is our input manager? It is, here's control. Yeah, this is the input manager. We need to apply them here. So input set, and if we hit the set button, and as long as we keep holding, it will keep calling this control. So O1 get control chip forward move. So this parameter is 0. I have not implemented the code of that parameter, which is the difference between the difference in time between calling the control. For example, if you want to hold the Z button for 4 seconds, for example, it will move forward for like the event would be called the first second and then the third second. So there is 1 second difference. You could implement that. Well, I want it to be automatically implemented using the third parameter, but it's not implemented yet. So yeah, okay. So input set for the Z button, and input held. As long as you keep holding, we will call this control. So why O1 get control chip F move while we have the control itself here is because when you assign, and I forgot it here, I'm going to assign the controls to the objects. So when you assign the chip forward move, for example, to the control, the object will have a copy of that control assigned to it. So the control itself is not assigned. Therefore, the self parent, this parent field is equal nil in this control, but it equals the current object in the object's control, that copy. So that's why we call O1 get control, which gives us back to the real control which has been assigned to the object. The reason here is because you can apply all of these controls to UFO objects, to anything you want. One control could be used by many objects. That's the philosophy here. And what else am I missing? I believe that's it. Yep, let's give it a try. Load project, Forensic X, Scene Inspector, Space Chunk, close this one, maximize, grab this one here. Okay, and I'm going to start simulation. And yeah, here I press the Z button, and go forward, S, backward, rotating buttons, because my keyboard is AZERTY, so probably not the same, and this is our chip moving. So we could apply a few more controls, such as if you press the space bar, it will shoot, or if you press the enter, self-destruction, for example, and each will be a control on its own. So now where's the chip? Where is the chip? Okay. Well, disappeared. Anyway. So basically that's it with the engine. I focused on the programming part here and not the editor features. I focused on the engine. More precisely the control features, the keyboard manager events. I'm currently implementing the mouse input manager, and there's a lot of work to do, so I don't really plan on releasing the engine anytime soon. I think that I would release first a stable version and yeah, so a usable version. That's better to do. So this editor will allow you to build to initialize your scenes and to initialize your objects position there. Yeah, I think it's better than coding them yourself. I think I have a better example here of demonstrates the use of the editor. I guess it's called Kenny. Yeah, it's called Kenny. Not sure if it works because I changed code way too much. Right? Yeah, it does not work yet. Anyway, so basically this example have too much sprites to build the Mario-like game, and yeah, I have a screenshot in my blog. So so this is my blog if you are interested. Sora.litabeps.fr. So iGame Engine. So this is basically the same example that we did, except that I only stopped here at the rotating UFO objects. I didn't when I wrote this article 17 days ago, I believe. I didn't write I haven't implemented the keyboard input manager yet. So yeah, this is a screenshot of that the same example that I was about to show you. And here you have a grid. You can create, you can move objects in as you do in tiled maps, and you can even move them out of the grid. So yeah, you don't really need to stick with the grid. And that's basically it. Yeah. Anyway, thank you guys so much for checking this video, for being interested in the game engine. I hope you guys did tell me all of your feedback, what you like, what you don't like about the game engine, and if you feature request, yeah, if you want me to implement anything else. Yeah, that's probably it. Thank you very much. See you guys next time. Bye bye.